Great to meet everyone. Like Skylar said, I know it's the end of the day, so we'll try to keep this fun and interesting. My name is Ryan Fox Tyler, co-founder and head of products and engineering at Hypermode. Previously spent 3 years at the data orchestration company Astronomer, and before that, a decade at a trillion-dollar asset manager in the dev platform. So I've seen dev platforms from a lot of angles and through a lot of transitions, and excited by what we're building with Hypermode, but really more excited to share some of the lessons we've learned through that. Right. And I like to start as we think about like how do people build agents and what does that actually mean in today's ecosystem and where are people spending their energy? I think about the peanut butter and jelly challenge, right? If you've not heard it before, it's this idea of you ask someone to take out a piece of paper and write down how do you make a peanut butter and jelly sandwich. And then oftentimes it's with kids and you will reenact exactly as they've written. You'll skip all the steps that they've skipped in their writing. But I think this is true in how we describe a lot of things. It's a lot easier to describe and teach someone incrementally how to do something than it is to take out a blank sheet of paper and remember every step along the way, right? Whether that's pulling the bread out of the package or where exactly to put the peanut butter or the jelly. Like these things are hard to remember up front. Humans aren't just naturally good at that, but through a conversation, you can enunciate that really well. And we think about that a lot of how we built out Hypermode and the agent construction process and where we think the energy should be. And then there's a set of lessons that we've learned through that at a technical level to support what it means when an agent can be constructed for nearly $0, right? And so we look at really this kind of loop of creating agents, right? You first was start define what their scope is, you connect them to the tools that they need to do their job, you train them on how to do specific pieces, and ideally you get in this loop with self-learning where it just keeps getting better over time. But I think a lot of people spend too much energy at the top part of that and not enough energy at the bottom part because they're still spending so much time hand rolling each one of these pieces, right? And so what we've learned in all the work that we've done with a lot of customers is people really should be spending less time at the outset on define and a lot more time at the training level, right? That's how they're going to know what works, what doesn't, what's possible with agents today, and what's frankly just not ready yet. The space is moving very quickly. What's possible in the market and the technology changes every day. And so we fundamentally believe that this should all happen in natural language, right? And that is why we built Concierge with this ability to actually create another agent through an agent, but it has some interesting technical patterns that emerge from that. But first, it can be hard to kind of grasp what this looks like. So let's actually take an example and start to look at what this is. So let me switch over to Hypermode. Um, this is our agent building experience. We think it operates best in natural language. You can eject a code at any point if you decide you want to, but really starts here, right? So an agent, as we know, is something that can take action, right? So I can go to our sidekick, our personal assistant that has access to my calendar and say, can you schedule a meeting for 5 p.m. today? Call it happy hour. It will go take that work. I don't have to give it any additional instruction. General tasks it knows how to do, and it can take action on my behalf. And so here we'll see it's creating that Google Calendar event and is now going to be available on my calendar, that happy hour meeting, right? It's really that simple. We're always surprised at how many people haven't even seen an agent that takes action like that. So we try to start people there. But the more fun is when we actually can go to our concierge and create a new agent. Let's do something a little more incremental, but just to show what this looks like, let's create a product marketer for Hypermode. And I'm not going to give a lot of information, right? This is not the peanut butter instructions where I need to go enunciate all the pieces. It's going to do the work, right? I'm going to ask the agent to come back to me and say, what information does it need to write the system prompt for my agent? It's going to ask about whether it represents a company. I'll give it hypermode.com. It's going to go out and do research about that company, right? About Hypermode, understand that, pull it into the context. It's going to do a better job of enunciating what Hypermode is, what its products are, where it sits in the market than I would just coming from scratch. We will call it LaunchSpark. And it decided it had enough information, and so it went off and created that, right? I could have spent more time working with this and giving it more information, but it decided it was enough, right? And so here we go. LaunchSpark has been created, and it should be popping up in just a second. Here's LaunchSpark. And it's as simple as that. We have our first agent. We can see here that it's written its system instruction for us. And if I scroll down, it picked GPT-4.1. I could swap it out for many of the other models that are available, right? Whether it's Gemini or Anthropic's models, right? I've got the choice within the platform. I can give it connections, right? Step one was define. We went through that really quickly. Step two is connect. I want to give my product marketer access to GitHub and to our product docs and ref. And there, it's as easy as that. I can start chatting with our product marketer and say, Mike, check, what tools do you have access to? And here, Launchmark is going to inventory those MCP servers under the hood. It's going to connect to those and pull out those tools. And so here we go. It's got the built-in tools as well as GitHub and our technical documentation with ref. Great. We've gotten through that connect step, right? We talked about we really want to get through those first two steps as quickly as possible. Then we go to train, right? So let's teach it how to do something. Let's update headline for hypermode.com. Can you fetch the current version? It's going to go out, right? I can say in one context, I'm going to teach it how to do these things. I'm not upset when it doesn't get it right the first time. That's okay, right? It's a little confused, right? There's a couple of different CTAs and headlines on here. So I'll give it some direction. I'm not talking about the meet your team. Can you propose 3 new options that are more fun? Right? This is a classic generation part of the journey. This is normal, right? And so I say, cool, let's go with number 3. Can you open pull request? Give it some nudge. Can you find the current headline in the code base and open a pull request to make the change? I don't need to teach it how to make a pull request. It knows that in its general knowledge, but it may run into some issues, right? It may have trouble looking for that current headline. Look, yep, I can dive into this search. I can see it found 134,000 results. It got a little overwhelmed with just that phrase. So I can say, look in Hypermode Inc./Hypermode repo. Again, back to these instructions. My goal is just get it to do the task once, and then we will take this and we'll turn it into a repeatable thing that my agent will have learned how to do. Looks like it's struggling, which is always fun. These systems always fail in slightly different ways. And it's just struggling with kind of constructing this query a bit, right? So why don't we take a step back. Look for and much like we wouldn't be upset with an intern that struggles, we don't get upset when the agent struggles here, right? We know that when we train it how to do this once, it's going to be able to remember this, right? So there we go. It found the search. It pulled the file contents. It's creating a branch. It's working on this next step. There we go. It's creating the file, and it's going to open a pull request on my behalf, right? It is taking action on my behalf. That's great. I could be someone that's less technical, don't know where this is, but here I just opened a pull request that made the change to that headline. Operating as me using OAuth, all of this is great. The real fun part, though, is when I hit this create task button. What it's going to do is going to take everything it's learned, take all those steps, and turn that into a repeatable prompt, right? And we think this is really that step of training our agents, right? It's very different than training a model. These are training agents like humans. These are standard operating procedures that we are teaching it how to do, right? And so you'll notice that it has struggled finding the file. It said, nope, it's actually right here. This is the object that I'm going to update. These are the other pieces. I hit save task. And now when I start a new piece here, my agent knows how to do that, right? So that's really the notion of getting into that loop as quickly as possible, training those agents. Let's jump back over here. So there's other patterns to this, right? It may feel like a little bit of a toy of, okay, I can let anyone create an agent in a few minutes. But there's other patterns for this dynamic creation of agents that you are going to see in real use today and emerging into new products. Right? The first is about spawning new agent instances. This isn't creating a new agent identity. This is creating a new agent context to work on a subpart of the problem. Right? So in this case, we're working with a company on a fraud detection agent. They may subdivide the problem to say, okay, agent A is going to go start to investigate one dimension of fraud, and agent B another dimension. Maybe agent C is going to be looking at the time it's taking to resolve this and looking at kind of the SLOs that they're required to operate on, and all going to roll back up to that. By maintaining those separate agent instances and that dynamic nature of it, you're able to actually constrain context to better manage the scalability of this system and to parallelize the work in a way that a single model can't, right? And so this becomes a very natural pattern for dynamic creation of agents. The other pattern we're starting to see is this idea of a conductor agent. And not just a conductor working across existing agents, but a conductor that's dynamically creating an agent team, right? If you say, I want to create a blog post with all the editing of it, but also the creative for it, you could have a conductor that spins up 4 different agents, separate context so they don't get confused or biased based on the original context of any one message, but also the ability to use separate models, right? We may use O3 for the writer agent and Claude for Opus, which is really good at editing for as an editor agent, and an image generation piece as their creative agent, right? That ability to dynamically create this and roll that back up is really close in the things that we're doing. And we think this becomes a natural derivative of that early work that we did to get Concierge out, to put it in people's hands to be able to easily create new agents. But that's only half the story, right? Being able to create agents quickly creates a lot of other challenges, right? If I think back to my days running dev platform at a large financial institution, the goal really isn't to say how quickly can I spin something up, it's how do I manage and operate that. And what we found is that the easier the path to production was, the more we could give leeway on that experimentation and that dynamic nature of it. And so what we did when we're starting out Hypermode is we built an actor-based runtime that scales this, right? At a technical level, the actor system is not new. It's been around for a very long time as a computational model to isolate resources and to have defined interfaces between them. But the thing that's really interesting to me about what it does here is that last point on kind of this feedback from my specialized agent is that ability to create new actors. And that gets really cool in where we're going with agents and their ability to spawn new sub-agents or new partner agents in their work is that kind of notion of this as an actor model, right? That runtime allows us to deliver a lot more features to our end users. And so when we think about, okay, what are the benefits of that? Why this is different than a library-based approach to this? That actor system creates a few really core things that are important for anyone in my mind that's thinking about scaling agents. One is that concurrency, that initial kind of just raw scale of, I have an agent that is doing great work. I want to scale it to 100,000 plus parallel agent instances. And you may be thinking about, okay, that's a lot of kind of parallel chats. Maybe I don't have that many users, but this isn't just about chats, right? This is about agents that are taking action, that are processing new inputs, whether they're connected to an event-based trigger or a schedule, to kind of managing those tasks, right? That we started training it on how to do. This is how we start to go to asynchronous work with our agents. It also means that when something fails, we have fault isolation and recovery, right? It's a core tenet of any real cloud service that I think we've lost in a lot of the work and kind of reinventing that around agents, is saying, how do I make sure that one crash doesn't impact others, right? How do I have isolation of my architecture from day one? And it's not something that I build out later. The third piece is really this event-driven design. This is what unlocks not just that synchronous chat that we all know as kind of working with LLMs, but also that ability for asynchronous task execution, for things like queuing up where needed, for dependencies to be invoked, right? And so that becomes really a key part of a resilient system. And that's another element of the agent or the actor-based or agent runtime here. And the last part is this clustered persistence, right? You want to make sure that you have persistence for long running tasks, especially, but you want to make sure that you don't have that overhead and you want to offload that into the cluster so that you have high availability, right? We know the cloud is not going to have stable VMs all the time, that they're going to rotate, that you need to build for those failure cases that is expected in cloud native design. And so that really becomes a key part of how we start to design agents for those underlying infrastructure primitives, is making sure that runtime absorbs some of that risk. And if we double click into one specific area of this, one of the things that gets me really excited about the actor model is this notion of passivation. And what passivation means fundamentally is that when an actor is not doing work, it's going to release resources back to the cluster. Well, this is really important because as much as we think about chat as a synchronous thing, it's actually a lot of small asynchronous events. And maybe there's some longer spurts where it's doing work for you or doing research, but there's actually a lot of idle time in between that. And you don't want at the application level to have to start to worry about that idle time and manage that underlying infrastructure. What you really want is a system, instead of being always on compute, you want it to have these serverless aspects of it without the overhead, right? The ability that you could be serverless in between chats, but you have 2 to 3 milliseconds of overhead as it scales back up to take the request and come back down. And that underlying thread state means that you're not starting from zero. You're not having to retrieve all this information or store it into a slow data store off to the side. You really are thinking about that as part of that inherent actor, that it has a state, that as it shuts down and maybe it resumes on a different node, right? These are common behaviors in a cloud, and it's able to maintain that state. Right. So these are all things that we had to think about when we said, okay, what if we weren't talking about agents as ones and twos, but 1,000 and 100,000s of them? How would you start to think about that problem differently? Right. Because that is the future that we're heading towards. And we're seeing very quickly that as we reduce the cost of creating that agent, then the next question becomes, if 1 out of 100 of them is successful, how do I make sure I scale that? Right, so if I come back to this original loop, right, this is where we want to see this happen, right? We want to spend a little bit of time on define and connect. You can always go back and revise those, but we want our humans to be spending a lot more time on the train and the self-learn, right? And that train also means that like you want the subject matter experts doing that training. In the fraud scenario, you want the person that's been studying fraud for 15 or 20 years, training that agent on how to do it, not a data scientist. The data scientist should be thinking about how do I get the right data in there? How do I understand different practices that are going to emerge? Much like MLOps over the years, right? MLOps is really focused on how do I build the platform for other experts to take some of these decisions and start to run some experiments. This is no different. If we want to think about the differentiation within agents, it's that train and self-learn aspect, right? It's how do you make sure that you're feeding it good context and making sure that it's able to make the right decisions at the right time. It's not defining agents and spending weeks doing all the plumbing. And that's the thing that we learn most. We hope that others kind of carry on with that because I think we're really excited to see what happens with that. So the thing I'll leave you with as we look at it all is say, if you really optimize the cost to experiment to be near zero and the path to production is simple, both have to be true. If you have one without the other, there's a lot of friction that starts to emerge, whether you have a great idea that you can't get to production, or you have such a strong production story that you don't actually have a low cost to experiment. But when you really combine those two, I've seen over and over again in my career and the people that I've worked with, I'm always surprised at what they're able to build. And so that's really the core learnings for us as we've at Hypermode as we built the Concierge. We built that actor-based agent runtime. It is open source. It's a framework called Modus. We encourage other people to use it as well. We think it's an important primitive, and we're happy to share that with everyone else and collaborate on it. So feel free to reach out if this is an area of interest. We always love talking about these kind of problems and how people think about whether lowering that cost of experimentation or increasing the scale of agents in production. So with that, I'll open it up for if there's any questions.
Awesome. Thanks. This was again, information dense. This was absolutely amazing. I feel like I have so many questions. I don't know that we have time for all of them, but folks, you can see on the screen there's some ways to reach out. Definitely take advantage of those. One of the things I was really curious about, you know, in creating like a new agent, like I often think about sort of like a lot of the context you would want to build that agent. And just curious, like, what are the different ways that Hypermode allows you to provide that context? Like, I often have like files, for instance, that have like a bunch of ideas I've been working on. And I'm just like, hey, sort through this and create something around that. So, are there ways for me to like link my knowledge into that?
Yeah, for sure. Right. So one of the things we have at Hypermode in addition to Modus is the open source graph database called dgraph, which is commonly used for structuring that context. Right. So we work with really large scale companies that are thinking about how do I scale this across my organization with context, or you have companies that are working really small context. Both are valid, right? You can do some really powerful things with just a little bit of context. And so we really focused on a tool-based injection of that. We think that is the way to have it live and fresh at all times. If you upload a file, that gets out of date really quickly, right? So we'd rather focus on how do we pull that from its inherent source, right? And that could be a note-taking app, right? It doesn't have to be these big enterprise systems. But yeah, that is everything, right? That we think about kind of the differentiation here. It's like what context am I bringing to the story, and how do I train it on things that I think are unique in the market. And so we try to make that really easy for people to get up and running in a few minutes.
Totally. One thing as you were going through the actor model and how you apply it, one thing that struck me is I feel like I've heard opposite takes, and so would love for you to
Okay.
just kind of like give your thoughts on this. But in particular, you discussed how each actor, and in this sense, each agent is independent, and they only communicate with message passing. So you don't have this shared state amongst them. And at the same time, I feel like there's a lot of people who in the industry talking about, hey, we should have agents that are constantly like contributing to a shared state. So how do you think about that? Do you feel like they're different? These are different ideas. Do you feel like they're in opposition?
Yeah, I think it's really about separating these layers of context, right? And so I think about state as like the most real-time context that if there's anything that matters of that, you're going to extract it pretty quickly, right? And then you kind of have short-term and long-term memories, right? Much like a human does. And so I think what's really important when you think about this is like, how do you have repeatability within a large scale system? And if every actor is constantly contributing to that short-term memory, then it can make it really difficult to understand how the system's going to behave from one day to the next. And that's really important for large organizations, especially regulated ones, is to have some of that predictability. And so by having separate layers of this, you can choose how you want to govern those pieces, right? Some organizations we work with say, look, I want my agents live contributing to long-term context and consuming from it. And so that becomes the interface. And that can be real time, but that can still be strict APIs and messages around that, right? Using the actor model still. Or some that are going to say, look, I wanted to contribute to a offline store where I can then review it. I can decide to upload those new memories into it. I can test and eval everything again before I publish that, right? It's a longer iteration loop, but it allows them to do it with control, right? To have repeatability, to kind of screen through those memories, to see how users may be trying to pollute it or attack through the memory, right? Because that is a real concern. And so I think it's really important that you have clear segregations within your architecture so you can make distinct choices of how you want to plug that system together.
Totally makes sense. I think we're just about out of time. So there's info there to reach out. I guess I'll leave with two notes or comments. First is I'm super excited about Hypermode. I was telling the guys in the chat, do I want to work at Hypermode? Just the demos were awesome. Blew me away. Loved it. Cool. Awesome. Thank you so much for coming. Thank you for sharing. I'm super excited to see what's next with Hypermode. And with that, folks, we're going to say bye-bye to Ryan.
Thank
Bye.
you.